Hello everyone, in this video you will learn how to import 3D seismic file step by step into Geomodeling's product. All products from Geomodeling share the same database and the same UI of data importing and exporting. To load 3D seismic data, you need to go to the top main menu, select Import 3D seismic data. A window will pop up to let you select the seismic file. You can select one seismic SEG-Y file, or if you have several seismic SEG-Y files that belong to one seismic survey, you can import them all. You can use Ctrl-A to select all of them in this page. You need to make sure the file type is selected as the SEG-Y 3D seismic data. Then click Open. The dialog can be easily resized. You can enlarge the dialog, or you can make it smaller to fit your screen. There is also a question mark at the upper right corner, which you can click, and then it will pop up. Another window shows the corresponding topic in the Help menu. This is the first step of importing 3D SEG-Y file. You can see first, this is the input file you selected. If you selected multiple 3D SEG-Y files in the previous dialog, then here will list all the 3D SEG-Y files. Please be aware that if you want to load several 3D SEG-Y files at one time, those 3D seismic data should be from the same seismic survey that share the same inline crossline information. And the most important thing in this page is to set the sample format for the SEG-Y file. Normally, it will automatically match the file you selected. You can use the drop-down menu to select different sample format. And this is for flip bytes or not. And you can check the seismic information from the header using this button. Once you click, you can see the header information of the SEG-Y file. Normally contains the inline crossline number, XY coordinates range, the sample format, datum, as well as other information. So that's one way you can QC the sample format. Another way to QC the sample format is selected correct or not, is to go to this preview. This shows the current trace of the seismic data, and we have different display mode: Wiggle, histogram, and spectrum. At the bottom there is a bar. You can scroll through different traces to see the preview of different traces for the 3D seismic data. If you select an incorrect sample format, then the preview will look strange. For example, you will see some strange patterns like this. That's the way you can QC if the sample format is selected right or not. After you make sure the sample format is selected right, then you can go to the next step. In the second step, you need to specify the start byte for the inline crossline and for the coordinate x and y. Again, for most of the time, this information will automatically match the seismic file. However, you need to always check it. You can check it from the header information, and it shows the inline number and the crossline number. Starts from bytes 9 and 21. So here, the start byte for inline crossline are correct. For XY coordinates, you can see it starts from 73 and 77. So these are also correct. However, the header information doesn't necessarily have this information regarding the XY and inline crossline. So if you cannot find those information in the header information, that's normal. Then you can use the spreadsheet at the left to judge which is the correct bias for inline crossline and coordinate x and y. So it says the inline crossline start bias from 9 and 21. You need to check the bias 9 and 21. So basically this value should be inline number and this value should be crossline number. And at the bottom there is a bar that you can scroll through different traces so you can see these values changes. So let's see these two numbers. When you increase these traces, then this number increases. And when it increases to certain values, then this value changes to 2. And then this doesn't change for a while, and this increases again. So this obey the rule that the inline crossline changes. So we can judge that this should be the inline and this should be crossline. And for the coordinates, we can see these two values seems like within the xy coordinates range. And as you change the traces, these two values changes. And if you see that those values are within the xy coordinates range, then those should be the xy coordinates. Then this should be the start byte for the coordinate x and y. So that's the way you QC the start byte specified for the line number and the coordinates. And another thing you need to make sure is the xy unit is selected correctly. Sometimes you will need to check this float checkbox to make sure that these values are correct. In this case, this should not be float value. But in some other cases, after you check this value will be correct value. And sometimes if these values are not correct, then you need to override XY scale and to enter a value here so that these numbers would multiply by the values you entered here, which becomes the correct XY values. And here, this part is for specifying the file coordinate system. If the seismic file is different from the project coordinate system, then you can select other coordinate system and use this button to select another coordinate system for the seismic file. If it's the same as the project coordinates, you can just select the second one, project coordinates. After you make sure the line number and coordinates start byte are specified correctly, you can select scan to scan the 3D SEGY file. So this is the third step of loading 3D SEGY file. In this page, you can see the 3-point coordinates for the seismic survey. You need to make sure these are correct. And this is the preview map for the seismic survey. And this shows the grid information. You need to pay attention to the inline space and crossline space. These two should show correctly. If there is something wrong in this page, you can see the inline crossline space shows none value, and the preview also show incorrectly. Then you need to go back to previous steps. It's because that in the previous steps you specify some parameters incorrectly. Then you need to change them and then go back to this step to see if this information changes to correct information. Then after you make everything is correct, you can go to the next step, which is the last step of loading 3D SEGY file. And first you can select to create a new survey, or you can select save to existing survey if there is any existing survey in the project already. And then you can define the data volume name and select the attribute using this drop-down menu. So now I just import one volume, but if you import several volumes at once, then you can see different volumes listed here, and you can change the volume name and attribute for each volume one by one. And at right, you can define the domain type for the volumes, if it's in time or depth, and define the seismic datum. This is very important. But if you forget to set the seismic datum at this stage, you can still do it after you import 3D seismic data. I can show you afterwards. And the unit you need to make sure is correct. And here it shows the original range of the seismic data. This cannot be changed, but here is the importing range, which you can change so that you can import part of the original range. Here is the first sample to wait time, and this is usually set to 0 for most seismic surveys. And the last one is output options. Please make this creating GTC Cube file checked, because this is for accelerating the visualization in different visualization windows within Attribute Studio project. This also shows the disk space available in your computer and the disk space required to import this 3D SEG-Y file. Then you can click Finish to import the seismic data. The seismic data will be saved under the Seismic tab in the Data Manager. You can see this is the seismic survey geometry, inline crossline time slice, subvolume, and your seismic volume. So if you forget to set the seismic datum when you import the 3D file, then you can double-click on the survey geometry to open its properties page. Here, you can still change the survey datum, and you hit OK or Apply after you change it. And for the 3D seismic volumes, you can check it in a 3D window. You can click to show its inline crossline time slice. And also the subvolume. You can right-click on the subvolume to show it as full range. You can also open new seismic section window to check an inline or crossline in a section. And you can change the inline crossline number using the bar at the top to see the different sections. And if you open a new base map window, you can display the time slice on the base map and change to different time slices to QC the seismic data you imported. This is the end of the video of importing 3D seismic file into Attribute Studio. If you have any inquiry, please send message to support@geomodeling.com. Thanks for watching.